Welcome back again. This is Quite for the Tech Lab channel. This is the last topic of the First Hop Redundancy Protocol. In this case, or specifically for this lab, we are configuring something called Gateway Load Balancing Protocol, or GLBP. But before we actually go into the definition or the official definition that we'll just ask from Google, we have to check and see what we have on this lab. So if we start from the top, we have this internet. Remember, this is for demonstrational purposes. Of course, on a environment or on a work environment or in industry, you cannot be utilizing this type of design. This is just for lab purposes. So we have single internet connectivity directly connected to those two routers. These are layer 3 devices via the interface gigabit 0/1 and also gigabit/01 on the right hand side. And if we go down, we can see that we have this switch. This is a multi-layer switch which is capable of handling traffic on layer 2 and also layer 3 when enabled. As you can see, we have this physical cable directly connected to the left hand side router via gigabit 0/0, and also on the right hand side we have this physical cable directly connected to the router via gigabit 0/0. Now let's go down to the end host devices. We are running Windows 10 on the left hand side. As you can see, if I click in here, you'll be able to see that this is the operating system Windows 10, and it currently shows that we have no unidentified network. So we're getting unidentified network, which means if we can run the command on the cmd ipconfig, we will be getting the APIPA as our IP address. In this case, I still have to come to this and assign the IP address on the network interface card. Okay, now let's go back to what is Gateway Load Balancing Protocol. Maybe let's just try to see according to the response that we're getting from Google. So the GLBP is a Cisco Gateway Load Balancing Protocol. What does that mean? This is not an open standard, which means it is a vendor specific protocol that is utilized on Cisco devices. So an FHRP, First Hop Redundancy Protocol, that uses an AVG, which stands for Active Visual Gateway, to manage a group of AVFs, active visual forwarders. The AVGs respond to the app or address resolution protocol request with different visual MAC addresses for each AVF, enabling load balancing and redundancy for the network default gateway. In a simple way, let's go back to the lab and try to simplify this. Suppose we have this device, which is actually a device that is configured with 192.168.50.1 default gateway. Okay, this device is sitting on a subnet mask network of 255.255.255.0, which means this is a class C IP address that will be assigned on this device. This device is trying to reach out to the default gateway for the first time. It's never ever in its life tried to connect to the default gateway or try to send traffic outside. Okay, what do we know about this device? We know that the IP address that we can actually give to it, we can give it 192.168.50.20 or any IP address on the network of class C IP address. Okay, so this device, when it asks who is the default gateway, it will send a broadcasting message. It will send a message to the switch, and the switch will not know who have that specific MAC address. So which means this MAC address will be actually broadcasted. The broadcasting MAC address is FFFFF. All of bunch of these F's, they represent that this is the destination MAC address of the unknown. So which means we're broadcasting to everyone whom we're gonna wait for their reply. They're gonna tell us that they actually own the specific IP address. Okay, in this case, as this device send a request to the switch won't know. There's nothing on its cache or the app table. There's nothing on the MAC address table currently, so it will have to learn some MAC addresses afterwards. In this case, it will broadcast to everyone except from the interface where it's received that request from, which means that this is the only um, interface that won't be sent back or won't be flooded with that MAC address of FFF. Okay, and then this device will drop the packet, because it will drop the frame because it's not the one that have that IP address of 50.1, and also this device will actually drop the packet if it's not. I'm just saying if it not, because we are using AVGs. We will see how actually this occurs. Okay, so if this is the gateway that actually active on that moment, this is the router that will respond and say, okay, this is my MAC address, blah blah blah. Okay, I hope that makes sense. But in gateway load balancing protocol, how does this works? Okay, remember we said that active visual gateway respond to the app request of each and every host or any device that is requesting to ask you who have that the default gateway's IP address. And then the active visual forwarders, they are actually responsible to forward the traffic off of the local subnet. These are AVFs. Okay, so the AVG will reply and says, okay, this is the MAC address of forwarder 1. You can speak with forwarder 1, and then that host will actually communicate with forwarder 1. If this is an active router at that moment, if this is the active router, which is forwarder 2 at that moment, the AVG will respond with the MAC address of this forwarder 2. It will say, this is the MAC address where you must send the traffic to. Okay, so in order for this device to reach out to the default gateway of .50.1, it will have to go through that physical address of MAC address 2 of forwarder 2. I hope that makes sense. Now let's check what we have here. This is the header. Again, it explains the same thing. We have made the example with this MAC address, the source MAC address, in which this is the MAC address of where we're trying to send the traffic, with the destination MAC address of what we don't know, and also we also know where we're trying to reach, which is 192.168.50.1, which is the default gateway, and also we have source IP of 192, which is the IP address that is assigned on the network interface card of this device. Okay, now let's see how do we actually configure that, or maybe before we deal with the configuration, let's go back and check what's the difference between HSRP, VRRP, and GLBP. HSRP is a Cisco proprietary standard also. However, it is based on layer 3, whereas GLBP is based on layer 2. Okay, and VRRP is an open standard, whereas GLBP is actually a Cisco proprietary as well. The advantage of the GLBP is because it can actually be able to do a load balancing using some mechanism of round robin, where the active forwarder gateway will actually receive the request from a specific host for the first time, and then it will respond with the forwarder that is actually active, the MAC address of the forwarder that is active, so that that host will send it to. If this PC sends another request, it will then respond with a different MAC address but on the same question. Okay, because this computer will have the same gateway as this computer. However, this will ask the question who have this specific IP address, and this AVG or active visual gateway will respond with the MAC address of the AVF or forwarder 2. Okay, because it will load balancing the traffic between the two routers. There is also another mechanism that can be used, which is called host independent and also weighted. In weighted, we can actually configure the interface or the router to have more weight than the other router in such a way that, let's say we have weight of 50 on the left hand side and we have weight of 100 on the right hand side, which means the router that is more reliable on the right hand side will be able to handle twice the traffic of router 1. I hope that makes sense. Let's move on to do the configuration and see how we can actually assign the IP addresses on all of these interfaces. First of all, because I'm using this internet, my home internet, which means I have a DHCP server that will be leasing the IP address on these interfaces, which is gigabit 0/1 on the left hand side and gigabit 0/1 on the right hand side. So let me go to this router on the left hand side and do the configuration. First thing first, we have to enable the router and type the command config terminal. Now that we are on a global config mode, we can be able to push the configuration to the router. In this case, let me try to put this down so we'll be able to see which interface I'm trying to configure. In this case, I'm trying to configure this interface with the DHCP. First thing first, I'll have to select the interface, which is interface gigabit 0/1, and then I will tell the router that I want to give the IP address of the DHCP to this router. I don't want to specify any static IP address. I just want to be leased with IP address that is available on the DHCP pool. In that case, I have actually typed that command. Now all I have to do is actually type the command no shutdown. Okay, as you can see, the interface is actually being granted. We have been assigned with the IP address of .10. Let me take a note of this so that we won't forget. Okay, so we have .10 on this side. Okay, the IP address in there is actually .10. Now while I'm still here, I'm gonna try to configure this interface, so we'll just move on once and for all. On this interface, I would like to use the static IP address. I'm not gonna enable the DHCP. Alright, so I will have to make sure that whatever IP address that I'm configuring, it should be part of the same subnet as the gateway load balancer, because this is gonna be handling our traffic to be actually active on both sides. Okay, so what we're gonna do now, we will try to give it an IP address. First thing first, we will have to exit from the current interface and select the interface that we're willing to give the IP to, which is gigabit 0/0 on the left hand side on this router. As you can see, we have 0/0. Now all we have to do is we have to assign the IP address on this specific router by typing the command interface it's IP add. We have to add 192.168.50. Let's think of any IP address that will make sense. Let's give it .30. Okay, so .30 255.255.255.0. remember this is class C, which is why we have that 3 octets being on, so we have to press enter here. It's saving the configuration to the interface. Let's give it some time. Now because by default the interface is currently down, So let me type in the command no shutdown, so that we'll be seeing the interface changing its state from down to up. As you can see, the interface have been changed with up in up line protocol, so the status is actually up. Okay, now we have to move on to this router before we actually configure the gateway load balancing protocol IP address. So let's go to this router and do the same thing. Okay, first thing first, on this router I'm gonna navigate to the global config mode, and from the global config mode I'm not gonna do something different from what I did before on router 1. We're gonna do the same thing. First thing first, we select the interface on the top, which is interface gigabit 0/1, and from there we just need to assign the DHCP by typing the command IP@DHCP, and the interface, because it is currently up, we will be assigned with the IP address from the DHCP server on my network. Okay, and as soon as we get this IP address, we will actually save this IP address of .16. I'm just gonna do this. I'll duplicate this, and we will have to, let me do this, we will take this and put it somewhere here so that we won't forget. And then let me try to put this as 16. Okay, so now we have .16 on the right hand side. This is just the IP address. Now let's go to the other interface, which is gigabit 0/0. Let's select the interface gigabit 0/0, and from there we already know that we're gonna assign the IP address of 192.168.50.40, 255.255.255.0. no shutdown. Okay, so what I'm trying to do here, I'm actually trying to use these numbers so that we won't forget. So I used .30 this side, I used .40 this side, so that we will always remember. This is just for demonstrational purposes. Again, in an industry you cannot do what I'm doing, even though it's quite the same thing, but the design will be actually different from what I'm doing right now. This is just to make you understand how the GLBP actually being utilized. Okay, so now we have to verify our configuration. What will make sense to us is that from this router we should be able to ping any device on the network, including the default gateway and of our router or our internet, and also on these interfaces gigabit 0/0, they should be able to ping each other or to reach each other. Why is that? Because they belong to the same network, or they belong to the same subnet, so they should be able to reach each other. Okay, now let's try that. Let's exit here and actually verify from dot let's verify from .10 and see if gigabit 0/1 can be able to ping to the internet. Let's do a ping to 8.8.8.8, which is the internet. As you can see, we can be able to reach out to the internet using that interface gigabit 0/1. Let me specify this by typing the command source gigabit 0/1. The reason why I'm specifying this is because I want to show you that when we're doing it from the other interface, we'll actually get the different reply. Okay, even though, or even if we have to do it twice, we will actually get the same result. The packet won't be able to pass through there because we have to configure some access list or access control list, and we have to also specify the net or configure the net in there if you're trying to break out to the internet from this source. But for now, let's test by trying to ping from this interface to that interface, because we know the IP address is assigned on both of these interfaces. For instance, I'm just gonna use the interface of router 2 from router 3, so from router 1. So we're gonna do a ping 192.168.50.40. We should be able to ping this router successfully because it is actually on the same subnet, which means the administrative distance is quietly actually 0. It is directly connected. The administrative distance is actually 0 on this between these two routers. Okay, so now what we have to do in this case, we have to configure this GLBP, or the gateway load balancer, that we are here for today. So how do we configure that? Same way as we've been configuring the HSRP and VRRP, but in this case we're willing to see what's gonna happen afterwards when we're having two devices requesting to reach out to the default gateway, to the same default gateway. We are expecting to see that the active visual gateway will actually have to reply with the MAC address of different forwarders, or active visual forwarders. Okay, so it will tell the host that, okay, you're gonna be talking to this forwarder and you're gonna be talking to this forwarder. Okay, now what do we do? Let's go back to route 1. This is route 1 on the left hand side. I'm just gonna try to exit this and ensure that we're doing the configuration on the correct interface. Hence we have to do the configuration on this interface, not on that exit interface of gigabit 0/1. Okay, we're not willing to configure this on an interface facing the internet. However, we're willing to configure it on this interface. So first thing first, let's verify our configuration. Do show IP interface brief. I want to see all of the IP addresses that we have assigned to our interfaces. As you can see, everything is actually how it's supposed to be. We have actually configured this interface of gigabit 0/1 using the DHCP, and then we have configured the gigabit 0/0 using the static entry. Okay, and the rest of the devices, they are administratively down, which means we cannot do anything about them at the moment. Even if you plug a cable in there, nothing will be functional unless if you configure the IP address on those interface. Now what we have to do again, we have to type in the command interface gigabit 0/0, which is this one, because we're willing to configure the GLBP on that interface. Okay, now we have to type in the command GLBP and we have to specify the group. If I type the question mark, you can see that the group is ranging from 0 up to 1023. Okay, 1023. In this case, I'm just gonna use group 10 for this demonstration, and then I have to specify the IP address on the same subnet as these interface IP addresses that are assigned in R1 and R2. In this case, I chose to use 192.168.50.1. Okay, so this GLBP is actually configured. Now we have to enable the preemptions, unlike VRRP where it's actually by default enabled. So as you can see, we have actually seen that there is this status which says there is some active staging in here. But before we check furthermore, as you can see, we have some forwarder 1 being active. As you can see, we have forwarder 1 being active. Sooner or later we'll check the MAC address of the forwarder 1. Now I want to continue, say GLBP of group 10 preemption. Okay, and then also I want to set up the priority, because I want this router on the left hand side to be an AVG. Okay, it must remain as an AVG while the other router will be AVF. Okay, so I'm just going to type the command GLBP10, and I will have to set up the priority to be lower than default priority of both routers, because by default the priority will be 100. So I'm just gonna lower it by 10, or by any value which is lower than 100. In this case, let me just make it to be 90. Okay, now I'm just gonna exit and save this configuration. Okay, what I've done this side is what I will do on the other side as well. Right, okay, do copy, run, start. Okay, let's save this to the startup config as well. Okay, now let's move on to the other router and do the same thing. We have selected the interface of gigabit 0/0, and we have typed the command GLBP, and hence, because we willing to have this configuration on the same group, we must always ensure that this GLBP group is actually unique, so it should be 10. And again, what you should note is that we can actually have up to 4 routers that can be utilized with the GLBP group. So let's carry on, assign the IP address. GLBP10 IP is the same, 192.168.50.1. As you can see, we will see the message which tells us more about this forwarder too. Okay, now let's do this config GLBP 10 preemption. Okay, enable GLBP. We can actually leave this to be on default priority of 100, but what you should take notice of, you should take notice of forwarder 2 being also active. So we have active session here, which tells us that this protocol is capable of doing a load balancing of the traffic. So if you have noticed on the previous First Hop Redundancy Protocol such as HSRP or VRRF, you would notice that we always have active and a backup on the other one, which is VRRP, and on an HSRP we had, so we on VRRP we had primary and a backup, and then on the which is a master, and also on the HSRP what we had is actually active, and we had a failover, okay, which is a secondary. In this case, as you can see, we will have to type in the command do show GLBP brief. Let's see a brief for now and see what's gonna tell us. Okay, what does this tells us? It tells us that we have an active forwarder 1 and we have this forwarder 2 which is listening. Right, what will going on here? Let's do this. Let's type in the command do show GLBP, which is we're willing to see the brief about all of this. As you can see, we also have this being active on this side. On the right hand side, we have that forwarder being active while the other one is actually listening. On the left hand side, on this router, we have forwarder 1 being active while forwarder 2 is actually listening. Right, so this is the MAC address of the forwarder 1 and this is the MAC address of the forwarder 2. Forwarder 1 is this side, forwarder 2 is that side, while on the left hand side, or on this router on the left hand side, we have the active session of forwarder 1 with this MAC address, the forwarder 2 is listening. And on the right hand side, while we have the active session of forwarder 2, the forwarder 1 is actually listening on specific IP address of 192.168.50.30, which is the IP address that we have actually configured on that interface of gigabit 0/0. If you want to verify that, we can type in the command do show interface gigabit 0/0. It's gonna tell us more information based on that interface. As we can see, the interface is actually up. This is the MAC address. This is the IP address that we actually talking about. This is the maximum transfer units or MTU bytes that we have, bandwidth and delays, reliability, transfer and receiving, load, many more. Okay, we have giants, throttles, CRC, we have frames, we have all of those runs and everything here, if you're willing to also see all of those. Collision, protocol drops, bubbles, lead collision, all of those. Okay, but what we're focusing on currently is actually the IP address, which is this one of forwarder 1. Okay, this is forwarder 1, this is forwarder 2. Now what we're willing to see what's gonna happen when we're trying to send some traffic or the packet originating from this host towards this gateway. For the first time, when we're sending it will go to forwarder 1, and as we send another one on a different host, it will go to forwarder 2. Why is that? It's because of load balancing. Alright, so remember we said the mechanism that is running here is round robin, which means it's always gonna be the first one to send will go to forwarder 1, the second one to send will go to forwarder 2, the third one to send will go to forwarder 1, the fourth one to send will go to forwarder 2. Same thing applies over and over again, unless if we manipulate that mechanism or we use another option of waiting, where we have to configure a certain router to have capabilities of handling more traffic than the other router. Okay, so let's do this now. All we have to do is we have to actually test, or we have to come to this end host device and ensure that, let me try to minimize this. We're gonna try to configure this device with the IP address that's gonna be on the same network as the default gateway as well as these routers. Okay, let me go to this Windows 10. Let me maximize this. As you know, to navigate, the shortest way to navigate to the configurations or to the control panel or for the network specifically, you have to type the command ncpa.cpl on your Windows or any operating system that's run Windows, and it will take us there to the network interface card, which is where we'll actually have to configure the IP address statically, because we didn't configure no DHCP server on that network. Okay, so I'm just gonna assign the IP address statically on this Windows host. It's gonna be slow because it's using my resources where I'm running on a Proxmox server. Okay, now let's assign the IP addresses statically. We have to type in the command 192.168.50. Let me just verify here which IP address that we said we're gonna use. We said we're gonna use .20, so let's keep on with that IP address of .20, and obviously the subnet mask is 255.255.255.0, which belongs to class C. Now let's go to the default gateway of 168.50 dot 1. Okay, we're gonna set our DNS as .8.8.8 so that in future, as we try to reach out to the internet, we'll be able to reach out to the internet. But for now, the network interface card will try to identify the network. As you can see, it already found a network, which is network 4. It won't be able to reach out to the internet because we still have to configure that net I was talking about, which is a network address translation. So it can be able to ping to the default gateway, and it can be able to ping .30 and .40, including .1. But what we're trying to do here, we're trying to send that ICMP echo request so that we'll be able to see which router responds as a forwarder 1 or forwarder 2. Okay, now let's go to the CMD and actually originate the packet from this device or from this host or from this Windows. Okay, let's give it some time. Okay, here we are. Okay, so from this device, what we're trying to do, we're trying to ping to 192.168.50.1. Okay, as you can see, this device, it can actually ping to a GLBP or a gateway load balancing enabled interface. Okay, which is visual. So in this case, what does that simply mean? It means if I run a trace set to that 192.168.50.1, I'll be able to see where this device, or which path did it took, or which gateway did it had to touch in order to reach out to the default gateway. Let's give it some time and see. And while we're running the trace routes on this side, we also have to go and verify on the routers as well. Okay, let's give it some time. Okay, it shows us the default gateway of the GLBP. Okay, it shows us the IP address of the GLBP. It doesn't shows us the actual hop. Okay, because it's the First Hop Redundancy Protocol. Okay, let's do this. Let's go to this. Let's go to this router. And type in the command do show GLBP. Okay, so I want to see what's going on here. This tells me that we have this group, which is group 10. The state is actually on standby. We have visual IP address of that, and we have hello timers of 3 seconds, and we have hold timers of 10 seconds. We have the next hello sent in the couple of 1.9 20 seconds, and we have that redirect time of 600, and we have forward timeout of 14,400 seconds. We have preemption, which we have enabled. We didn't configure any delay statically or manually, and we have this interface which is active for now. This is the active forwarder at the moment, and we have the priority of 100, and we have a standby which is local on that router, which is the router that we currently on its global config mode. And also we have the waiting of 100, which is also on the default. We didn't change this waiting that we were talking about, so both routers, they're handling the wait equally. Okay, so we have the certain threshold of lower and upper, and then we have load balancing, which is default round robin. And then we have these MAC addresses, we have these groups, and we have these IP addresses, We have two forwarders. The first one is active, which is forwarder 1, and then we have state, which is active. Now let's go to forwarder 2. Forwarder 2 is actually listening. As you can see, the state is actually listening. It's learned via this make address, and we know that this is the owner's ID. Now we have this as the active one. So let's do a brief again. As you can see, we have actually this as our active forwarder. Okay, this is what is our active forwarder at the moment. All right, now let me try to initiate a ping from this. Just gonna try to initiate a ping from that device. Let's give it some time. Let me switch it off and switch it back on. Start. Okay, this machine is actually struggling to start. I wanted to show you that when we're trying to actually send from a different host, we can be able to see or observe that this traffic, as it's being sent toward the default gateway, the forwarder will actually reply with a different AVF or with different MAC address, which will handle the traffic of the local subnet. Okay, now let's try to let's go back to this router. Do show gateway load balancing protocol, or let's do this. Do trace route to 192.168.50.1. Okay, we're trying to see what. Okay, as you can see, to go there we have to go through that interface. Okay, to get to that .50.1. all right, do show GLBP. Let's see other things that we can actually check in here. We can see the capabilities. Okay, let's see what else we can also check here. If we want to see the listener, let's see the standby. It shows us all bunch of this information. Let's see other commands as well that we can actually utilize here. The details. It shows us the same information that it was showing on the other command as well. So let's go to try and ping to the internet. Remember, won't be able to ping to the internet as a result that we have to configure that ACL and not to allow the traffic from inside to go outside. so that this computer will have the internet. Okay, so we will see once the computer have the internet, and we will try to use tracking. We will also try to bring some of these interfaces down to see that the other interface will actually we will see that this is actually gonna be the router that will handle the traffic as the other one goes down. So this will become the AVG and AVF of its own, okay, as the other one goes down. So now let's configure what we called ACL. Okay, so access list, and then let's see which number we can give, because we want to just use a standard access list. As you can see, we have different ranges, from 100 to 199 is actually the extended. The list goes on and on and on, so we're just gonna use access list 10, and we want to actually permit anything. Okay, and we want to actually say IPNet. We want to select the interface first, which is interface gigabit 0/1 IPNet inside. It's actually outside. Let's say IPNet outside. Okay, let's give it some time while it's doing that. Okay, I'm just gonna go through. Okay, here we are. Let's select another interface. Let's select the other interface, which is gigabit 0/0. This is gonna be IPNet inside. Okay, exit. Let's go to the other interface on this router and do the same thing. Enable config terminal. Interface gigabit 0/1 IP, or is IP net outside. Let's give it some time. Okay, now let's select the other interface, which is interface gigabit 0/0 IPNet inside. Now let's configure access list on the global config mode. Access list 10 permit anything. Okay, now let's do another ping 8.8 8.8.8 from source 0 gigabit 0/0. Okay, it's gonna drop the packet. As a result, we need to configure one more command which will tell this interface to actually overload. Okay, so we will have to type the command. So in order for us to ensure that this router can be able to ping to the internet using this interface gigabit 0/0, we type the command ipnet inside with the source list of the group of the access list that we have actually configured, and we have to select the interface which we're willing to overload. In this case, this is the interface that we're willing to overload. So what does this mean? It means as the IP address, different IP address exit from that interface, they will use one IP to communicate with an outside world. So in this case, we have to overload interface. We have to select the interface first, sorry, gigabit 0/1, and then we have to select the overload. Okay, this is actually being configured already. As you can see, it's already being actioned. So in this case, I can verify this by typing the command do ping 8.8.8.8 from source of gigabit 0/0. You'll be able to see that now we can actually being able to reach out to the internet. As long as we have that interface being able to reach out to the internet, that switch, because it's acting as a layer 2, it should be able to reach out to the internet when we run the ping from any device that is connected to it. Okay, such as that router as well. If we can run do ping 8.8.8.8 from the specific source of gigabit 0/0, we can see that we have sent some ICMP echo request, and then we got some replies. We sent 5 and then we received 5. Okay, so which means this router also can be able to reach out to the interface using this interface of gigabit 0/0. Now what about this PC over here? Let's see if we maximize this. As you can see, it have this. So let's type in the command ncpa.cpl. Okay, it's actually taking time. It's taking longer than expected, but it's coming. Okay, it is opening Microsoft Edge. I think I clicked the wrong button. Now let's try again. Let's go to a CMD straight. While we're waiting for that Microsoft Edge, also we can actually verify by going to Google and ping or try to get any downloadable page on the internet. Okay, let me just say speed test, or let me just say Google. If it doesn't work here, then I will have to go to the control panel and disable the interface or the network interface card and re-enable it, so that it's going to pick up the new configuration. Okay, it looks like something is coming up, although it's taking longer. That's because of my resources that are actually given to the specific device. Okay, we're gonna come back to this. Let's just leave it running for now while it's still trying to download, and then we're gonna come back to it. But I can see it's trying to download the content of the page, which means this device is receiving the internet. And the other way to find it out, let's go to the router that I'm using, and we actually gonna be able to see we're actually gonna run a simple script. I'm just gonna add it as part of the netwatch script that we have in here. I'm just gonna try to ping that interface of 192.168 dot 50 dot we said it's 20, and then I'll just try to put some comment. Windows 10 is up. Okay, this will actually send the message to my email to tell if that device can be actually reach out to the internet. Okay, currently it looks like it is down. Let's go back there. Maybe let me try to ping from here and see if we have it route to that interface. Okay, we don't have no direct routing configured to reach out to that interface. Okay, let's see if I wanted to ping .30 as well. Okay, I cannot ping any of those devices, so I cannot be able to track it. The reason I'm trying to do that is because it looks like it is very slow in here. The resources that are added to this device, they actually low, so I will have to bump up the memory and the CPU. CMD. Okay, so as you can see in background, we have something looks cool in there, which means it's trying to download the page. However, but the resources, because it doesn't allow it to pull information so quick, it is taking it's taking it slowly, so it takes very slowly download the page. Okay, so we have the internet on this PC at the moment. We can also verify using the command line interface. This is what I'm going to try and do right now. I'm just going to leave this Microsoft Edge. Let's just use a CMD to verify if we can be able to trace or ping the internet. Okay, let me just pause this video until it respond the way it's supposed to respond. Okay, now we are on this CMD or command line interface. So let's try to ping to 8.8.8.8. As you can see, we have actually latency there. However, we can be able to ping, and we can try to run the continuous ping to see if we have some drops. As you can see, we can actually ping to the internet on this computer itself. Alright, using the default gateway, which means we have used the IP address of GLBP, of the load balancing. So how do we check that? By typing the command traceset to 8.8.8. we want to know how did we actually get to that 8.8.8. so it's going to tell us that we actually used this forwarder 2, and we actually gonna see now. Okay, it's taking longer. I'm just gonna run another ping. So let me run another ping. There was another ping, and then I'm gonna run another traceset. Okay, so let's do it again. Okay, so it's telling me that it went to forwarder 2, and it told me that it further went through to my default gateway of the DHCP server. Okay, so let's come in here and search speed test. Okay, it found the page on the internet. Now presenting all of the information based on this page. Okay, so let me just exit from here. Is it taking time? Let me just exit from here. As you can see, we have that speed test, blah blah blah. It's trying to download all of the content of this page. Let me just leave it like this. But the bottom line is that this device have the internet, and it can be able to communicate to the internet using the IP address of the default gateway, which is pointing to the IP address of the gateway load balancing protocol. And the gateway load balancing protocol, it can determine which active forwarder can be utilized to respond to the which can be able to respond to the traffic request on the local subnet. Okay, so now what we can do is we can also enable tracking of this interface, same way that we've been doing on HSRP and VRRP. Let me see, we have .10 in here. So if I were to change this into .10, and also if I were to change here to what is this, let's say router 1 underscore Cisco R1 Cisco gigabit 0 slash 1, and then I can just say gigabit 0 slash 1 here, and let me copy the same command and go to what will happen if this interface actually reports down. Is not reachable. Up is reachable. Okay, so let's see if we can change this IP address to .10.88. Let me do this. It's 192.168.88.10. Okay, as you can see, this interface actually this interface actually sent the message now, which tells me that this host is actually up. Okay, so this host is actually up as I've actually configured that interface tracking. But now on Cisco interfaces, we've been doing all along, we've been tracking the interface using the line protocol of this interface in such a way. How should this router be treated based on this interface? Let's say if this interface goes down, we don't want to use this path to forward the traffic to the interface using AVFs. So we would like to change the priority of this device to be actually higher than hundreds or higher than the other priority of the other router on the network, so that this will become AVG and become the active forwarder all the time while this interface is still down, until the interface come up, and then because of the preemption, this router will actually take its place again. I hope this video was so informative to you. Let's meet again on upcoming videos.